Trigonometric formulas, we can add and subtract, so some sine of a plus b or sine of a minus b. It's going to be sine of a, cosine of b, plus cosine of a, sine of b for the addition of the angles. Subtraction, it's the same thing but minus. Cosine of a plus b. Cosine of a plus b is cosine of a, cosine of b minus sine of a, sine of b, and cosine a minus b is cosine of a, cosine of b plus sine of a, sine of b. Tangent, if tangent of a plus b is tangent of a plus tangent of b divided by 1 minus tangent of a times tangent of b, and subtraction is tangent of a minus tangent of b over 1 plus tangent of a, tangent of b. So find the exact value of tangent of pi over 12. Well, pi over 12 can come up with pi over 3 minus pi over 4. So the tangent of that subtraction is tangent of pi over 3 minus tangent of pi over 4 over 1 plus tangent of pi over 3, tangent of pi over 4. Tangent of pi over 3 is root 3. Tangent of pi over 4 is 1. And simplify, we get root 3 minus 1 over 1 plus root 3. Multiply by the denominator's conjugate, and that gets us to root 3 minus 3 minus 1 plus root 3 over 1 minus 3, or negative 4 plus 2 root 3 over negative 2, divided by negative 2 gets us 2 minus root 3. Find the exact value of the tangent of 75. Well, I can get 75 degrees from taking 30 degrees plus 45, and then we run through the same process, except with the addition on top, subtraction on the denominator. Tangent of 30 is 1 over root 3, and tangent of 45 is 1. So we plug those in, and that top I can get to be 1 plus root 3 over root 3. The denominator is going to be root 3 minus 1 over root 3. So there's the top, 1 plus root 3 over root 3, and then multiplied by the reciprocal of the bottom, root 3 over root 3 minus 1. The root 3's cancel, and I got 1 plus root 3 over root 3 minus 1, multiplied by the denominator's conjugate. That gets us root 3 plus 1 plus 3 plus root 3 over 3 minus 1. So 4 plus 2 root 3 over 2 gets us 2 plus root 3. Next, still working with addition and subtraction formulas, we want to find the exact value of the cosine of a plus b, and we're given that a is 7 over 25 and a is in the first quadrant. Cosine of b is negative 4/5, and it happens to be in the second quadrant, so draw a couple triangles. First one, let's go with a, and 7 over 25 would be the side relationship for the sine. 25 squared minus 7 squared gets us this 24 squared. And then for b, that's going to be in the second quadrant, and negative 4 over 5, and that's a 3, 4, 5 triangle, so that side's positive 3. And then cosine of a plus b is going to be cosine of a, cosine of b minus sine of a, sine of b. So 24 over 25 times negative 4/5 minus 7 over 25 times 3/5 gets us negative 96 over 125 minus 21 over 125, which is negative 117 over 125. Next one, write tangent of the arctan of 1 plus the arc cosine of x as an algebraic expression. So start with working with that arc cosine of x. That would be the relationship, so the missing side would be square root of 1 minus x squared. Now we've got everything we need to fill in, because it'll be tangent of the arctan of 1 plus tangent of the arc cosine of x over 1 minus tangent of the arctan of 1 and tangent arc cosine of x. Well, the tangent of the arctan of 1 is just 1. And the tangent of the arc cosine of x is going to be square root of 1 minus x squared over x. Fill those in. And then that top I can simplify to x plus square root of 1 minus x squared over x if I make it one fraction. And the bottom is going to be x minus the square root of 1 minus x squared over x. The x's cancel, and we end up with just x plus the square root of 1 minus x squared over x minus the square root of 1 minus x squared. We can kind of stop there. One of the last ones before try some sum and addition. We want to prove that the tangent of x minus pi equals the tangent of x. So plug it into the formula. Tangent of pi happens to be 0. So tangent of x minus 0 over 1 plus tangent of x times 0. That bottom just simplifies to 1. Tangent of x divided by 1 is just tangent of x. Simplify the expression sine of 5 pi minus theta. Well, work with the sign subtraction. So sine of 5 pi cosine of theta minus cosine of 5 pi sine of theta. Sine of 5 pi is 0. Cosine of 5 pi is going to be negative 1. So that gets us 0 plus sine of theta, which is just sine of theta. Now here's some addition and sum and difference formulas to practice with, and then check with me. And some more. And then we get double angle formulas. Sine of 2u equals 2 times the sine of u cosine of u. Cosine of 2u has 3 different versions, and we can work with any of them. Tangent of 2u is 2 tangent of u over 1 minus tangent squared of u. I mainly only use that one if I don't have to find sine of 2u and cosine of 2u, because if I have those two, I just divide them to get the tangent. So solve 3 sine squared x plus cosine 2x minus 2 equals 0. Right there, cosine of 2x kind of looks like I want to use that bottom formula, 1 minus 2 sine squared of u, because then that gets everything in terms of sine squared. So I've got sine squared x minus 1 equals 0. So sine squared x equals 1. Sine squared x equals plus or minus 1, and that's going to be at pi over 2 and 3 pi over 2. So all of my answers will be pi over 2 plus n pi, where n is an integer. Use tangent of u equals what? Well, equals 8 over 15, and happens to be in the third quadrant to find the sine of 2u, cosine of 2u, and tangent of 2u. So that means if it's in the third quadrant, both 8 and 15 are negative, and then our missing side is going to be 17, using the Pythagorean theorem. And so sine of 2u is just 2 times the sine of u cosine of u, so 2 times negative 8 over 17 times negative 15 over 17, which is 240 over 289. Cosine of 2u, I'm just going to use cosine squared u minus sine squared u, so negative 15 over 17 squared minus negative 8 over 17 squared, which is 161 over 289. Tangent of 2u is going to be 2 times the tangent of u over 1 minus tangent squared of u, so 2 times 8 over 15 over 1 minus 8 over 15 squared. Gets us 16 over 15 over 1 minus 64 over 225, which gets us 16 over 15 over 161 over 225. And if I take 16 over 15 and multiply it by the reciprocal of 225 over 161, or, you know, I could just take 240, the first fraction of sine of 2u, 240 over 289 divided by 161 over 289, and I would get 240 over 161. Rewrite sine of 4x in terms of sine x and cosine x. This is working with the double angle formulas. Again, sine of 4x I could write as sine of 2 times 2x, and that's 2 times the sine of 2x cosine of 2x. Sine of 2x again would be 2 times the sine of x cosine of x. And cosine of 2x, I'm just picking the bottom one, 1 minus 2 sine squared of x. That just simplifies to 4 times sine of x cosine of x times 1 minus 2 sine squared of x, which can be simplified as 4 sine of x cosine of x minus 8 sine cubed of x cosine of x. Power reducing formulas, how we can reduce the powers. We want to rewrite sine squared of x, cosine squared of x in terms of first powers of the cosines of multiple angles. So sine squared is going to be 1 minus cosine of 2x over 2, and cosine squared is going to be 1 plus cosine of 2x over 2. That gets us 1 minus cosine squared of 2x over 4, and we can pull out the 1/4. And then we want to rewrite that cosine squared of 2x. And so that's 1/4 times 1 minus 1 plus cosine of 2 times 2x over 2. That gets us 1/4 times 2 minus 1 minus cosine of 4x all over 2. And I can pull out the 1/2, so 1/8 times 1 minus cosine of 4x. A lot of this is working with the formulas and simplifying as you can. Half angle formulas. Find the exact value of the tangent of 105. Well, 105 is half of 210. So I'm just going to work with 1 minus the cosine of 210 divided by the sine of 210. Cosine of 210 is negative root 3 over 2. Sine of 210 is negative 1/2. That gets us 1 plus root 3 over 2 divided by negative 1/2. So 2 plus root 3 over 2 times negative 1/2 gets us negative 2 minus root 3. Find all the solutions of cosine squared x plus 4 sine squared of x over 2 equals 1. So we're working with the half angle formulas there. And so I can start with the sine squared of x over 2 is going to be the same as, this is like working with the power reducing, so sine squared is going to be 1 minus cosine of 2 times x over 2 over 2. And that simplifies to cosine squared of x plus 2 times 1 minus cosine of x. And then we can simplify that a little bit. Cosine squared of x minus 2 cosine of x, and then we would have had a plus 2 minus the 1 from the other side. That factors into cosine x minus 1 times itself, so just set one of those equal to 0. So that means cosine of x equals 1. Where does cosine of x equal 1? Well, it equals 1 at x equals 0. Rewrite cosine of 2 theta, sine 7 theta as a sum or difference. Well, we're working with cosine and sine, so we look at that product to sum, and we're looking for a cosine sine. That's that bottom one, so now we just plug it in. So we'll have 1/2 times the sine of 2 theta plus 7 theta minus sine of 2 theta minus 7 theta. So that's 1/2 times the sine of 9 theta minus sine of negative 5 theta. And I can simplify that because a sine of a negative is a negative of the sine. So 1/2 times the sine of 9 theta plus sine of 5 theta. Next one, find the exact value of cosine of pi over 12 plus cosine of 5 pi over 12. That's a sum. We can rewrite it as a product. We have cosine plus cosine, so that would be like this one. Plug in what we've got, so 2 times the cosine of pi over 12 plus 5 pi over 12 all over 2 times the cosine of pi over 12 minus 5 pi over 12 all over 2 gets us 2 times the cosine of 6 pi over 12 divided by 2 times the cosine of negative 4 pi over 12 divided by 2, which that simplifies to 2 times the cosine of 6 pi over 24 times the cosine of negative 4 pi over 24, which is just 2 times the cosine of pi over 4 times the cosine of negative pi over 6. And cosine of negative pi over 6 is the same as cosine of pi over 6. And that's 2 times root 2 over 2 times root 3 over 2, which is just root 6 over 2. Next one, we have a subtraction, and it's cosine minus cosine, so that's this bottom one here. Plug in again what we've got. But a little bit of simplifying, we got cosine of 2 times 3x minus cosine of 3x. That gets us 2 cosine squared of 3x minus 1 minus cosine of 3x, because we're solving this, and notice I didn't quite use that up there. I just went and used a power reducing, well, not a power, I used a double angle formula. And so that gets us something that we can factor. So we got 2 cosine of 3x plus 1, set that equal to 0. Take cosine of 3x minus 1, set it equal to 0. So cosine of 3x equals negative 1/2, or cosine of 3x equals 1. And let's see, for the negative 1/2, that would be at 2 pi over 3 and 4 pi over 3. For the 1, that would be at 0. And then we divide all of those by 3. That gets us 2 pi n over 9, 4 pi n over 9, and 6 pi n over 9. And if we take a look at those, if I go 2 to 6 to 4, that would just be 2 pi over n times 1 times 2 times 3. So that means we can just write it as 2 pi n over 3, where n is an integer. Gets us all of our answers. And then you've got some practice with those trig formulas: double angle, power reducing, half angle, product to sum, sum to product. Recognize what you've got, plug it into the formula, and simplify as best you can on these.